simplify p squared minus 3p minus 4 all over 2p squared plus 14p plus 12 and find its domain. So here, first off, we can see we have a trinomial in the numerator and denominator, which means we're probably going to be factoring those trinomials. And in the numerator, this could be factored into p minus 4 times p plus 1. And first off, in the denominator, we can see all three terms have a common factor of 2. So let's factor that out. And so we're left with p squared plus 7p plus 6, right? All three terms have been divided by 2 because I factored it out. And this trinomial here can be factored into p plus 6 times p plus 1. And now you can see that we have p plus 1 in the numerator and denominator, and so we can cancel those out. And so all we're left with is p minus 4 over 2 times p plus 6. And that's your final answer, but you could argue that what is simpler is p minus 4 over 2 times p, which is 2p, plus 2 times 6, which is 12. So that these are equivalent. You could argue either is more simple. As for the domain, it's the values of p that make the denominator equal to 0. That's the restrictions on the domain. And so if we set that equal to 0 and do similar things, factor out the 2. And in this case, we divide by 2 on both sides, so I just get the trinomial left. And I factored into p plus 6 and p plus 1, similar how I did here. And so we solve for p. So if we have two things multiplied by each other, and they're equal to 0, that means either one of them has to be 0. And so if p plus 6 is equal to 0, then p is negative 6. And if p plus 1 is equal to 0, then p is negative 1. And so the restrictions on our domain are all numbers, or our domain is all numbers except for negative 6 and negative 1.